Welcome to this lecture series in coordinate geometry. In this lecture, we want to discuss this problem. Let me read it out. So we have a rectangle OHFM whose sides are 11 and 5 units. So this is 11 units and that is 5 units. And we have three distinct points A, B, C such that, they are points on the plane of course, such that H is the orthocenter of triangle ABC. So there is some triangle ABC where H is the orthocenter. So what is the orthocenter? Recall orthocenter is the point where all the three altitudes of the triangle meet. Okay, and O is the circumcenter. Circumcenter is the point where all the three perpendicular bisectors of the three sides meet. So O is the circumcenter. M is the midpoint of BC, so M is somewhere here. And F is the foot of the perpendicular dropped from A. So the line passing through A and going through H is necessarily the altitude because H is the orthocenter. So F is this point. And what we are given is that this is a rectangle and its dimensions are 5 units and 11 units. So I will make a much better diagram in the next slide, but this is the data given to us. The question is, what is the length of the side BC? Okay. So this is a problem in pure geometry, plane geometry. This has nothing to do with coordinate geometry, but we will solve this using coordinate geometry. As usual, you're encouraged to pause the video before we look at the solution I'm going to discuss. And with that, let us proceed. Well, pause the video to solve the problem, not just pause the video. Okay. So this is the more proper diagram. We have the triangle ABC. This rectangle is here where H is the orthocenter, M is the midpoint of BC, O is the circumcenter, and F is the foot of the perpendicular dropped from A because it is the line passing through A and the orthocenter. So basically this is the diagram and we need to find the length of BC. Now this diagram is not very accurate, but it illustrates the problem very well. So we will use coordinate geometry, and to start we will set up our coordinate system like this. So this will be the origin, the x-axis will be parallel to this line, y-axis will be parallel to that line. Alright, so the coordinates of O will therefore be 0, 0. The coordinates of H would be minus 11, 0. The coordinates of M are 0, minus 5. And that of F are minus 11, minus 5. Okay. Let's say the coordinates of B are minus x, minus 5. So this length, this much, sorry, so let me say that again. So this length, that is what we are calling x. But since we are going towards the left of the origin, the coordinate will be minus x. So we don't know x, and therefore we have chosen a symbol for it. And of course, the y coordinate of B will be minus 5 because we are descending down by 5 units. Now, since M is the midpoint of BC, this length and that length are the same. This length is x, so that length will also be x. So the coordinates of C are x, minus 5. Okay. And lastly, what are the coordinates of A? It's minus 11, something. We don't know this something, so that is, let's call that y. So this is minus 11, y. Fine, so these are the coordinates, and now we can use the data given in the problem. First, we will use the fact that H is the orthocenter. So if we join this line, these 2 points, we draw this line, this will be 90 degrees. The figure is not very accurate, so it doesn't look 90 degrees, but it will be. So the product of slope of this line and that line will be minus 1 because the product of slopes of two perpendicular lines is minus 1 as long as none of the lines are vertical. So if we use that fact, what we get is the slope of the line BH is 0 minus 5 divided by minus 11 minus x. That's the slope of BH multiplied by slope of AC. Slope of AC is this number and this is -1. So if we make it a little bit civilized, this is -1, and we get, yeah, we'll have to calculate this, but I think what we will get is this equation. Yeah, just cross multiplying, we get this equation, which let's box it for the moment. So that is one equation, but one more equation we can easily get because O is the circumcenter. So this distance is same as that distance. The circumcenter has this property that it is equidistant from the three vertices of the triangle. Okay, so just using that gives us the distance between O and A squared is y square plus 11 square. And the distance between O and C squared, the distance between O and A, the square of it is this thing, and now we are using the distance between O and C and squaring it. So that is equal to x square plus 5 square. So we get, yeah, this is another equation. So now there are two equations, two variables. If you solve it, what you get is x has to be a positive number because x was a length. X was this length. So x is positive, and even if you get two solutions, I don't really remember what were the solutions, but I mean the answer that you will land up at is this. X will be 14. And therefore the length of BC would be twice of x, which is 28. So BC is 28. Yeah, so just solve these two equations. That's the part I'm skipping. Fine, so I hope you enjoyed this solution and this problem. As usual, like, comment, share, subscribe, and I will see you next time.